Microphone check. 1 2 1 2. Microphone check. 1 2 1 2. Welcome back to the Coding Fanatic YouTube channel. I'm your host, Richard Clark, and here at Coding Fanatic, I teach new Android developers like you how to grow quickly. Whether it's committing to your projects, learning new skills, or the best ways to work with others, these are the pillars that I focused on to grow as an Android developer. Now I'm passing my lessons on to you. And if it sounds like content that you are interested in, then join the mailing list over at codingfanatic.com. Welcome back, everyone, to another Building Apps Quickly live stream. This is live stream number 6, and tonight we are going to continue where we left off. For those of you who are new here, I've been working on a timer application, something that can be used as a stopwatch. I followed a tutorial by another YouTuber known as Code with Cal. Shout out to him. And I finished the tutorial in last week's live stream, but I came across a couple of bugs, and I wanted to, well, yeah, they're more logical errors, but a bug is a bug, right? 2 + 2 does not equal fish. That's what we say around here. So anyway, I came across a couple of bugs with it, and I spent some time working on it and wanted to show you guys what I discovered and how to fix it. Now, for the folks at home who are new to Android development or to software development as a whole, you might feel a little lost right now. Just know that I found someone who gave me a list of steps to make this. It's a timer, it's a stopwatch. You hit start, it keeps track of the time. You hit stop, it pauses. You hit start, it tracks the time. You get it. Hit reset, boom. I followed your instructions. The app works, but there are a couple of kinks that I wanted to that they didn't fix in their tutorial. So what I found was, well, shoot, I have 2 options here. I can either find a brand new tutorial and start from scratch, or I can try and fix these things myself. Cal still gave me the basics of what I need for the stopwatch, but there are still a few other things that need fixing. So without further ado, let's get started. gave me the basics of what I need from the stopwatch, but there are still a few other things that need fixing. So, without further ado, let's get started. All right. Get my notes in order over here so that we can get this thing going. All right, so the first thing that I noticed with this application, now on the surface, it looks like a regular stopwatch application. Everything looks like it's working. Please a bit. I found I was yelling a bit last time. So on the surface, it looks like a standard stopwatch application, but the first issue I found was there is a bug where if you spam the start button, you'll see that the seconds continue to increment. That's not how a stopwatch is supposed to work. Spamming, what do I mean? Well, if I hit start and then stop to pause it and hit start again, you see the time goes up. Each time you press start, 19, 20, 21, 22, and so on. Each time you press the start button, the time increments by 1. Now, that's not logically, that's not supposed to happen. So that means that there's some error somewhere in the code that needs fixing. So what I found was if we open the, I'll even show you how to get there. The Java app, Java timer service. So if we look at the timer service file specifically, you'll see that here in the on start command, this is the method that is used to kick off everything. This is the start command. So when you when you press start, the start button, this is the method that gets invoked. So we have a value, a variable time, you pass it an intent.get double extra, and default value is 0. So all right, and then timer dot schedule at fixed rate time task. All right, so we pass it the time, and so now our timer, the actual time object here, we have a timer object that's used to control the value, the data that's used for the timer that we see right here. Timer dot schedule at fixed rate time task, and you pass it the variable time and some interval. Now, time task, this method is over here. Or excuse me, this is the inner class that we created last week or a week before. So here we are returning a timer task object, right? So we go to, all right, override function run. So when this runs, whenever you press start, we have an intent variable, pass it an intent, increment the time, and then intent.put extra, and you pass the time and send broadcast intent. So in order to generate this timer task, what you need to know, in order for us to get this thing going, we take the time, we increment it by 1 or 1 second, and then we pass it back, and that's what we see here. So over here in time task, this interval, the delay is 0, period is 1,000. So what this does is, starting from 0, every 1,000 milliseconds or every 1 second, we're going to invoke this run function, meaning that in this run function, you increment the time by 1. So every second or every time that you hit the onStart command, time gets incremented by 1. So start command increments by 1. Start command increment by 1, and so on. This is the problem. So in order to fix this, the first thing I found was if you move the time increment below the invocation of the intent.put extra, it'll use the current time first and increment the time second. What we're doing here is incrementing the time first and then using the current time. We don't want that. So, and also, this is the biggest giveaway here. When you hit start, the second immediately hit 1. 1 second has not gone by yet. So to fix this, boom. Okay. And we're gonna refresh everything here. All right, so now as you can see, when we hit start, 1 Mississippi, 2 Mississippi, 3 Mississippi. All right, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8. So now when we hit the start button, the time starts at 0 or whatever value it's at. And after 1 second goes by, then you will see the time increment. So this is a more accurate representation of the time. But I said it's more accurate. It doesn't mean it's quite perfect. All right, so that's our first move. All right, so our second move here . Our second move here is, let's take a look at this schedule at fixed rate. Now, what Cal did here was set the period to 1000 milliseconds or 1 second, because a millisecond, you get it. Every second, we are going to invoke this time task method with the current time, meaning that every second, we're going to increment the time by 1. We're going to change this to 1 so that every millisecond, we invoke the time task method. Now, just for fun, I'm going to show you guys what that looks like in a second. You'll see why I'm doing it in a minute, but I just need you to trust me. So now, as you can see, when we press start, every millisecond, the time task is firing. So we know that time doesn't go this fast, but there's a method to my madness. All right. Now you see, we want something to happen every millisecond, but we don't want the time to increment by 1 every millisecond. All my super mathy people probably will have figured it out by now. Our next move will be to, instead of incrementing the time by 1, we're going to increment it by 1,000th or 0.001. Meaning that every millisecond, every 1,000th of a second, the time will increment by 1,000th of 1. Now you might be asking yourself, Richard, what's the difference? Are you a nerd or something? Why does it have to be so exact, so precise? What's the point? I mean, you press start, it's gonna do the exact same thing. 2 Mississippi, 3 Mississippi, 4 Mississippi, and so on. What's the difference? By setting the period to 1 millisecond and incrementing by 1,000th of 1 every 1,000th of a second, it's way more precise. Now, if we were human beings counting on a playground, then yeah, counting 1, 2, 3, it makes sense. But because we are using a phone, we're using a computer here, the phone can count at 1,000 at a rate of 1,000th of a second. So, I mean, why not use it, right? So this will make it more precise and allow us to have a more accurate value or have a more accurate measure of the time that has passed. Remember, this is a stopwatch. When you watch the Olympics and you see Usain Bolt go out there and he's running around the track, they don't count it by seconds to the T. They have a fraction down to the fraction of a second to tell you who is the fastest in the world. So when we're creating our stopwatch, we want to have that same level of accuracy, right? All right. So by updating the increment to 1,000th of one, it'll make this feature much more effective. Okay. All right, so just to test this out real quick and show you that this has been fixed, if I spam start, you'll see that it takes a while for the start button to increment, or for the time to increment. There are two reasons behind this. The first one is because the value is more precise, it tracks the time increment a lot better. The second reason is if we had left this as 1 then and left the period as 1,000, then because this only fires every second, you would have to let the timer run for a full second before it increments. And I will give you guys a perfect example of what I'm talking about. Let's put this back for a second. All right, put that back to 1,000 and say time plus equals 1. This is the same thing as time plus 1, but because I'll just leave it like this. This is essentially the same as saying time is equal to time plus 1, but you shortchange it and just say time plus equals 1. All right, so save it, and so that you guys can see what we're doing here, we're going to log get the time. And we'll also import the log class. Okay. All right, so what this statement will do is in the logcat, it's going to display every time this function fires, it's going to display the actual value of the time variable so you guys can see it live. All right, so let's save it and let's run this bad boy. Okay. All right, so start. Okay, that's better. All right, so every time I press start, it should, or let me reset it actually. Okay, so we press start, 4, 5. So you can see that the value is updating. 8 seconds, 9 seconds, 10 seconds, 11, and you can see it. You can see that represented here. So it looks like it works, right? But let's see what happens if I pause it before a full second has passed. So pause it, and pause it again, and pause it again, and pause it again. So as you can see, the value is not increasing at all. It's still staying as 15.0. Once a full second goes by, this will update to say 15. But if you don't allow an entire second to pass, the timer, and you keep hitting start and stop over and over, the time will never increment beyond another second. So that's the reason why I decided to change this to, instead of incrementing by 1, increment it by 1,000 or 0.001 and set the period to 1 millisecond instead of 1,000 milliseconds. This way, every millisecond, this thing is counting. That's how a stopwatch is supposed to work. All right. So let's clear the logcat. Save. Terminate. All right. So now, if I hit, you gotta move quick now. Oh, I didn't double click. All right. So if let's reset it. Clear logcat. All right. All right. So if I'm quick enough, you see as I'm spamming it, you can see here that the number is increasing by fractions of a second, by thousandths of a second. So we've got, let me just clear it and start again. Gosh, it's so difficult because it's so fast. We're talking about fractions of a second. All right, stop. All right, so we've got 0.001, 2, 3, 4, 5. So every thousandth of a second that went by while I clicked, it incremented by 0.01 for each of those. So just to show, and on top of that, this is to show you a measure of accuracy. If you scroll to the bottom, even though the timer reads 0, I was able to double click in 0.135 seconds. So that's pretty good. That's very impressive. It's pretty good. So yeah, this change by setting the time to increment by 1,000th and setting the period to 1,000th, you get a much crispier and much more accurate read on the amount of time it's passing the stopwatch. Let me just take one quick second to update my notes here. Okay. Nope. Is my mic still? How's the mic still going? Really weird. Not as weird as that. Okay, just making sure you guys can still hear me. Yeah, I don't know what was going on. We had a bit of a stereo effect going on for a second. I don't know why that happened, but all right. So now that we have finished, we moved the timer, increment below the invocation of the input.put extra. So this way it uses the time before incrementing it, and we change it to increment by 1,000, and we set the period to 1, which would be 1,000th of a second. Cool. I showed you guys the results of what happens if you press start and stop and how it tracks the time. If you wanted to, you could just hold down the N key and this work. Yeah, there we go. So you can see the time updating in real time down here, right? All right, let's clear the logcat and reset here. All right. Yeah, so this has been pretty good so far. I gotta say I'm very proud of myself. Log the time value. Shit. I demo this. I'd have to do that first. So int to int. Truncate. Okay. Now, I have to admit that even though we've made it this far, don't let the success fool you now. Because even though we made it this far, we're not quite finished yet. And anyone who's got a careful eye, you guys already know what's left for us to fix. There's one tiny little small detail that needs to be fixed. All right, so there's one more thing I want to show you guys before we wrap this up. If you look at the timer, I'm going to minimize this guy so you can see it a little clearer. If you look at the timer, you'll notice that, actually, it's better if I show you. Right now, the time value is 0.426. So we have 426 thousandths of a second, right? Now, watch what happens when I spam it one more time. The time is set to 1. Now, the seconds value says 1, meaning that 1 second has passed. But if you look in the logcat, hasn't even been a full second yet. So how can this be? How can it be that we're storing the time, and while the time is equal to 0.6, when it's equal to 0.3 and 0.4 and 0.1 and 2, and nothing happened. But once it got to 0.5 and 0.6, all of a sudden the seconds increased. Okay? Even if we do it again, when we get to 1.563 seconds, it says 2. It hasn't even hit 2 yet. So how can this be? I'll tell you how. Somebody's rounding. That's right. Cal did the bad thing, and he started rounding the time up in order to display the amount of time that's passed. I'm just joking. No, but for real though, that is the reason why. If we go back to the main activity method now, or class now, if you look right here, In the get time string from double method, this is the method that's used to actually set the time that you see here in the application. And it accepts a variable type double. So it takes the time and then it breaks it down into it basically uses some division here so you can get the hours, minutes, and seconds that have gone by. So if you, yeah, it gets the hours, minutes, and seconds that have gone by. Here, there's a variable called an integer called result integer, and it's equal to time.round to int. So what this does is first take the time value and set it to round it to an integer, so that you can then use division to process the amount of hours, minutes, and seconds. If you guys want to, for a quick rundown of this, a quick example of it. If we change the time to increment by 1 every millisecond, let's say hours, let's say you've been timing something for an hour and I don't know, 25 minutes. So using this math, you take the time and you break it down. So you got 5,114. All right, so you get the remainder of that divided into 86,400 divided by 3,600. Okay, result int. Mod 86,400. Let's do some math. I'm pretty sure that there's like a 24 in here somewhere just cause. All right, so if you take 86,400 divided by 3,600, okay, it's 24. Divided by 24 is 213. So that's not it. Seconds, minutes, hours. Okay. Oh, okay. Never mind. I get it. So, all right. Let's not use days let's not use the hours as a. Oh, I guess you have to use that as an example because people are gonna wonder, Rich, how do you even get to that? All right. Shoot. I don't understand how this modulus operator works in Kotlin. So we're going to take a quick second to look into it real fast. There's value there somewhere. Wrong screen. Arithmetic operators. Okay, Kotlin. Tutorialspoint.com. Alright, returns the division remainder. These are relational operators. Okay, so example is x, y. Alright, so then result int modulus A6400 over 3600. Gotta say, this doesn't really do it for me. Let's find an example. Okay, 33 schools. Returns the division remainder. Try it. All right, perfect. Print x mod y. All right, how about x equal to, all right, so here we have an example. We're gonna do x equals 5, y equals 2, print line x mod y, which is 1. So 5 divided by 2 is 2.5. No, sorry, these are integers. 5 divided by 2 would be 2 with a remainder of 1. So 5 mod 2 is 1. I think this is probably just a better way to do it instead of using variables. Right, so you get the same. Oh man, that's slow. There we go. You did it. Yeah. All right. So 5 mod 2 is 1. If you did 6 mod 2, it should be 0 because 6 divided by 2. 2 divides evenly into 6, so there will be no remainder. So let's go ahead back to our code, and we're just going to copy this line in here. All right, so let's see if we can, let's use a different example that will make more sense to us. All right, so we know that the time is 5,114, right? So what this is saying is 5,114 mod 86,400 divided by 3,600 should be equal to 1. And that's how you get the number of hours that have passed by, right? All right, so 3,600 is the number of seconds, which would be an hour. So I just don't understand why the 86,400 is here. It's gonna give us 1. I just don't understand why. It's not 5,114 mod 86,400. But we know that 5,114 divided by 3,600 equals 1 point something. All right. It's either this is processed first or this is processed first. If it's this first, then the answer would be 0 over, this would be, there would be no remainder because 5,114 is less than 86,400. So this should give you 0. Let's run it. $5,114 mod 86,400. I guess because it's less. Let's see. You still get 5,400. All right. What if you did 2 mod 5? Let's see what that would yield. Would that be 2? Oh yeah, it would be because it's not 5 divided by 2. It's 2 divided by 5, and it won't divide evenly. So this should yield 2. All right. Never mind. Okay. So 5,114 mod 86,400 divided by 3,600. Ah, so then this would be the same as 5,114 divided by 3,600. And because they're integers, it won't give you a decimal value, so you'll get 1. Okay, I get it now. Cool. So, shout out to Tutorials Point and W3 School. These guys are like my bread and butter for software development. All right, so move this guy back here. All right, so when our time is equal to 5,114.0, right? Mod 86,400, you get the same number. If this number were to exceed 86,400, then you would get that remainder mod 3,600. All right. And so the answer would be that divided by 3,600, which is 1. All right, we do this again here to say mod 86,400, which you know is still 5,000 and some change. Mod 86, whatever is 1, and then 1 divided by 60. Oh boy, I'm confusing myself. This mod, this 51. This mod, this would be 1.42. All right, you know what? We're not gonna go over all the mathematics because it will be here all night, and I'm slow to pick up on this stuff. But just know that if the time is equal to 5,100, let's say you were to measure 5,114 seconds, this is what it would equate to: an hour, 25 minutes, 13 seconds. All right, cool. So we got that far. But the problem with how this is being processed is that the time is being rounded. And so the time doesn't actually fully jump up before it's calculated here. So let's reset the timer. Oh, why did I change this to every second then? Oh boy, hang on, y'all. I'm with it. I'm gonna be back. I'll be right back with it. Give me 1 second. Right, I changed this to every second so you can see whole numbers. Right, so this is the issue. I'm with it now. The issue is that the time is rounded to an integer. So if you had some arbitrary value, like say 49 minutes and 58 seconds, then you still wouldn't have the decimal. You would just have the number of seconds exactly that have gone by, right? So this is or dang it, I'm lost again. All right, the reason why you should not round this to an integer is because you won't get an accurate read of time when the number of seconds is always going to round either up or down. So the display, even though the time is being stored appropriately, I'm going to actually change this back, but even though the time is being stored appropriately, it's not going to reflect properly in the app, and I'll show you. Okay, so right now it's showing point. Once it crosses 0.5, it rounds up. All right, and that's a problem because now the time display does not match the actual time stored. So while an integer is necessary for processing the numbers that you see in the display, you should not have to convert there's a way to do this without rounding the number. You can get the integer, but you don't have to round the number out, and I'll show you guys how to do it. All right, so the first thing we're going to do is we are going to truncate the time. Now, truncating is what that does is take the decimal and remove it from the number. So let's say our number is 0.603. Instead of 0.603, it'll just be 0. If your number is 1.5834 or whatever, your number is 1. So truncating a number truncating a decimal takes the decimal out and just leaves you with the whole number. So that's no different from when you have a math problem like 5,000